Okay, so hopefully you already completed the bell ringer. We will go over this tomorrow because tomorrow's bell ringer won't apply since we're skipping, not skipping, but we're pushing things back. So go ahead and take out that worksheet that you picked up when you walked in. We're going to do odds together, and then you're going to do evens for homework, or hopefully you can finish it before you leave. So simplify each rational expression. Now, we struggled a little bit with just the plain simple ones with rules of exponents. So I want to take the time to make sure that we did a couple problems together. So for 1 and 3, there's really not much to do. There's no factoring involved. It's just the basic rules of exponents. So when you go left to right, just look at the numbers first. So 140, we have to think about the greatest common factor that goes into 140. Well, the biggest number that divides evenly into 140 is 20. So I'm going to divide the top and bottom by 20. Okay. Get myself ready to go here with a fraction. So when I do my division, I get 100 divided by 20, which is 5, and then 40 divided by 20, which is going to get me 2. Okay. So the numbers are done. So when we look at the letters here, there's a couple ways you can do this. Again, you could look for the greatest common factor and divide both top and bottom by it. That's fine. You could think about it in your head, or you were doing rules of exponents. I like to think about it as a number system. I have 1x on top, 2 on bottom. Well, one of them is going to cancel, leaving me with only 1x. So because there's 2 x's on the bottom, that 1x that's left over is going to go on the bottom. So that 1x is going to be going on the bottom there. Again, that's because there's 1x on top and 2 on bottom, and look, 1's left in the bottom. Okay, in green, I have 5 y's on top and 2 on bottom. What you're technically doing is subtracting. 5 minus 2 gets me 3. So I have 3 y's left over. We just need to figure out where they belong. Do they belong on the top, or do they belong on the bottom? Well, because we have 5 y's on top and 2 on bottom, I'm going to be left with 3 y's, and they're going to be on top because 5 is a bigger number. Okay. And then this last one here in the z's, I have 3 z's on top, 4 on bottom. So that means I'm going to have 1 z left over, and it's going to be on the bottom because there are 4 z's. Again, a visual for yourself. There's 4 z's on bottom, 3 on top, gone, gone, gone. There's 1 left in the bottom. Okay. So then all of these problems mirror the next question. So number 2 is going to be just like number 1, and so on as we go down. Okay, so you have to do the evens. So let's do the next one. Again, go in order. I like to just do the numbers first. 27 and 18. The biggest number that divides evenly into 27 and 18 is going to be 9. So I'm going to divide the top and bottom by 9 so that I'm able to reduce that fraction. Well, 27 divided by 9 gets me 3. And then 18 divided by 9 gets me 2. So I kind of got my fraction set up there. Well, in blue here, I have 4 x's on top, 3 on bottom, which leaves me with 1x, and it's going to be on top. Again, because you have 4 on top, 3 on bottom. 3 of them are going to cancel, and 1 is going to be left on top. Okay, in green, I have 4 on top, 5 on bottom. That leaves me with only 1. Again, you're always subtracting. I would always take the bigger number minus the smaller number. 5 minus 4 gives me 1. So I have 1 y left. And because 5 is bigger than 4, the y is going to be on the bottom. It's that simple. Okay. And then the very last one here for the z's, I have 3 on top, 1 on bottom, which is going to leave me, again, 3 minus 1 gets me 2. So I have 2 z's left. And it's going to be on the top, again, because the 3 is bigger. Okay. And that's our final answer there. So again, you have 4 to do. Okay, so for this one, simplify each rational expression and state the excluded values. Remember, the excluded values are things like x cannot be what? What makes the bottom equal to 0? So for this one, first step is always to factor. Okay, so when you factor, it looks like this. So we can't factor the top. So I'm just going to rewrite the top, x minus 4. But I can factor the bottom. So the factoring of the bottom, the GCF, is going to be 3. Okay, so when you factor something out, your greatest common factor, you're actually, what you're doing is you're dividing everything by it. So I'm going to divide both pieces by 3. Okay, when you do that, what's left is x minus 4. Second step, what are the excluded values? What can't x be? X cannot be positive 4 here because that's what makes it 0. Step 3 is just to cancel everything that you can. So if you take a look here, these cancel, which leaves me with 1 on top. So I get 1 over 3 is my final answer. 1 over 3. All right. This next one. Okay, this next one. So again, the top, greatest common factor. The GCF here is going to be 4x because both of them can divide by 4x. So 4x, the first step, factor, take out the 4x. What's left when you divide both pieces by 4x is going to be x minus 1. All right, if this is moving too fast, you can always press pause. All over 6x squared. Now again, state the excluded values. X cannot be 0 here because when you plug in 0 right here, that's going to get you 0 on the bottom. If you put 4 divided by 0 in your calculator, it doesn't work. Okay, and last step is to simplify if you can. So 4 and 6 can reduce to 2 over 3. Okay, can reduce to 2 over 3 because you could divide the top and bottom by 2. Now, when we take a look here, I have 1x on top, 2 on bottom, which leaves me with just 1x, and that 1x is going to be left on the bottom. That's my final answer. Okay, 8 is just like number 7. Take a look at this next one. There's 2 GCF problems. The greatest common factor at the top is 4. The greatest common factor on the bottom is 3, because those numbers are the numbers that can go into both of those. So 4 and 3 are on the outside because, again, whatever the GCF is gets written on the outside. But when I divide the top both by 4, that's going to leave me with x minus 7. Same thing with the bottom. When I divide both of these by 3, I'm going to be left with x minus 7. Second step is to list the excluded values. X cannot be positive 7 here. It's always that opposite sign. Last and final step is to simplify what you can. Gone, gone. All I'm left with is 4/3. Is my final answer. Okay. This one, a lot's going on here. This one looks like it's going to be a GCF problem. So the greatest common factor between 6x squared and 18x is going to be 6x. So again, we write that 6x all the way on the outside. Right? So I divide both of these pieces by 6x, and I can see, what's left over when I factor that out or divide each piece by that. So 6x squared divided by 6x just gets me x, and then negative 18x divided by 6x just gets me negative 3. Whenever there's 3 terms, you're going to do the MA tables. This one is what multiplies to 15 and adds to negative 8. Well, when you make your table, 1 and 15, that's not going to subtract or add to get 8. 2 doesn't work. 15 divided by 3 gets me 5. Well, they both have to be negative in order to add to get negative 8. Okay, so what's nice about these easy ones is you can go right to the end. X minus 3, x minus 5. Okay, that was the MA table. Second step, list the 2 excluded values here. X cannot be 3 and x cannot be 5. Last and final step is just to simplify what you can. So gone, gone. If you look here, what's highlighted, 6x divided by x minus 5. 6x divided by x minus 5. Done. You can put the parentheses in. You can leave them out, whatever works for you. All right, so let's go ahead and flip the page. And take a look at number 13. So this one, you guys are really good at difference of 2 squares. We call that dots, difference of 2 squares. And that's when you square root both of them. So remember, the first step is a factor. Well, the square root of x squared is x, and the square root of 64 is 8. So you would just write x plus 8, x minus 8. That's difference of 2 squares. This one, whenever there's 3 terms, you use the MA table. Remember to use that purple sheet all in the front to help you out. So what multiplies to negative 16 and adds to negative 6? Well, 16 divided by 1 gets me 16. That's not going to get me 6. 16 divided by 2 is 8. If I subtract those, I am going to go ahead and get my negative 6, which is really nice. So I have x plus 2 and x minus 8 as my factors there. Second step, list those excluded values. X cannot be negative 2. X cannot be 8. Then take a look. Gone, gone. This is what's left over. You can leave the parentheses if you want, or you can take them out. Doesn't matter. But this would be your final answer. Again, always feel free to pause if need be. Okay, so this one, we got two MA tables here. So they're both the MA tables because they're both trinomials. So this guy is what multiplies to negative 5 and adds to 4. This guy is what multiplies to negative 20 and adds to 1. So let's talk about the top first. So we remember we have the factor, both the top and the bottom. So the only thing that multiplies to 5 is 1 and 5. So we have to figure out the signs for us to be able to add to get 4. So I have positive 5 and negative 1 would be my numbers that satisfy that. This one, go in order. 20 divided by 1 gets me 20. Not going to work. 2 works. 2 and 10. Okay, doesn't add or subtract to get 1. 3 doesn't work. 4. 20 divided by 4 is 5. When I subtract these with a positive 5 and a negative 4, that's going to help me, and that's going to get me what satisfies, what multiplies a negative 20 and adds to 1. So we would write it like this. And we need to list our excluded values. X cannot be negative 5 here, and x cannot be positive 4. And the very last step is to actually write out what the simplified version is. That's gone. And I'm left with x minus 1 all over x minus 4. My final answer. Now again, you could put parentheses in if you want. You don't have to. Okay, 2 more. This one. When we look at number 17, again, all of these go together. So 17 and 18 will be exactly the same. Okay, this one's a GCF problem. The greatest common factor here, 9 is the number that goes into both 9 and 81. Also, that you take out the x squared because that's also common. So 9x squared is going to be written on the outside. Remember, you're dividing both these pieces now by 9x squared. Well, 9x cubed divided by 9x squared, that's just going to get me x. And then negative 81x squared divided by 9x squared is going to just leave me with a negative 9. Then this one is called difference of two squares, where you take the square root of both. Well, when you take the square root of both, you get x and 9. So you have x plus 9, x minus 9. That's the first step. The hardest step is the factoring part. And I know factoring is hard. I get that. Got to keep practicing. We've been doing it for a while now. 2, list the excluded values. X cannot be negative 9 and x cannot be positive 9. Go ahead and cross out what you can, gone, and look what's left over, and we're done. So I have my final answer is 9x squared all over x plus 9. Done. Last one. Okay, this one was like the one on the homework from last night, and a lot of people got it wrong, so I added it on to here. It was kind of challenging. You can't do anything with the top for the first one, so I'm just going to rewrite that. On the bottom, it's greatest common factor. Okay, so when you do your GCF, the number that goes into 27 and 36 is 9. And then you can also take out 9x. Make sure to write that on the outside. Well, when you divide both of them by 9x, let's see what happens. I get x, 3x, because 27 divided by 9 is 3. And then 36 divided by 9 is 4. So take a look at that. That looks kind of weird. You'll notice that when we do our excluded values, this one's 0. This one we kind of have to talk about. Let's go off to the side. 3x plus 4, what makes that 0? Okay, we got to figure that out. So we subtract 4. And the next step to solve for that would be to divide by 3. So the excluded value here is negative 4/3. That one was a hard one in the homework, so I kind of want to go over one like that today. I wouldn't worry too much about that type of one. But let's go ahead and simplify it, and then we'll be done. So again, the 3x plus 4 is not going anywhere. There's nothing that cancels. Let's take a look. 18 divided by 9 gets me 2. And then x squared divided by x leaves me with just a single x on top. And I'm done. So again, I know that factoring is hard. There's probably a lot to take in. And hopefully today kind of helped you a little bit with the confusion from yesterday. The hardest part is the factoring. And if you struggle with factoring last semester, it's going to be tough. But you got to keep pushing forward and keep trying it. The only way to get better is to keep practicing it. Use that purple sheet in the cover of your notes to help guide you with, what direction to go. Okay, it tells you kind of how to do that. If there's 2, it's different to 2 squares. If it's 3, you got to do the MA table. Okay, so again, try to use those examples. But again, the best examples are the ones that we just did, because 19 and 20, look how similar they are. Okay, 17 and 18, look how similar they are. Okay, so take the rest of the time, work together, work alone, listen to music, do what you need to do, but really try to focus on getting better at the factoring. Because it is pretty crucial if you're moving on to the next level next year. I hope you have a great day. As always, if you need to check your answers, the answer key is in the binder. Okay, have a great day.